Okay, guys. So we said that the third type is stress due to bending, and this one we used to give it the sigma sub b, where b refers to the word bending itself, and the one that you got, the form that you got to use last time, it was mc/2, if I remember. Am I right or wrong, guys, about this form that you used last semester in the mechanics?
No,
it was my over I think.
Yes, over I, Doctor.
No, this is the one that I used. This is the one that I used yesterday. I'm talking about the one that the form that you used to use in the mechanics of material. It is m what? Remember?
No, I don't.
I guess
Anyway,
it was MC over I.
Okay. I'm gonna use the one that I mentioned yesterday, guys, which is m times y over I. Okay. At this moment, right? We did not get this point, right? So now, guys, we need to understand what does it mean by sigma bending is equal to m times y over I. First of all, I need to check on the dimensions. As you know, the stress is what is Newton per meter square or millimeter square, right? So to be sure that the right side of my form is okay, I have to end up with the same dimension. Let's try. Okay. Usually, guys, when we are
لا،
الصوت انقطع يا دكتور.
النت عندي انقطع.
you don't know when I have some problem here with the
ايوه دكتور الحين نقدر نسمعك.
دكتور ما في صوت يا دكتور. أحد يسمع يا شباب؟
لا ما نسمع.
لا
انا مو سامع.
الصوت انقطع.
لا انقطع صوت الدكتور، اتوقع الكونكشن عنده سيء.
مكتوب ريكونكتنج فوق يسار.
Okay, how about now, guys? Do you hear me?
ايوه الحين نسمعك.
تمام الآن يا دكتور.
I'm sorry, something is going wrong with the connection. So now, guys, I'm getting back to this one, as I mentioned, just to be sure from any form that you are using that this form is okay. This is not only for machine design 1 by, guys. This is for any course that you are studying. If you are not sure about which symbols or which letters should be on the right side and on the left side, just to go and check on the units. Okay. So now I'm doing this business to show you how to do it. Now we know that the stress is force by area, which is Newton per millimeter square. And now let's go to the right hand side and check on the units. The moment is what? What are the units of the moment, guys?
Newton meter.
Moment is
yes. Newton meter or Newton times millimeter.
Millimeter to the power 4.
يا راجل يا طيب. M is Newton millimeter. Y is millimeter.
Yes.
And the I is millimeter to the power 4. Okay. 4. So now, if we cancel out 2 millimeters with 4, you will end up with power 2, which is Newton per millimeter square. This means that my form is okay. Okay. So now let's get into the details of the form. Before I get into the details of the form, guys, I would remind you with the example that I gave you yesterday. I'm assuming that my beam or my cantilever is composed of a stack of papers. Okay, stack of papers, group of papers, and I put them actually in a stack, and I'm gonna hold this stack of paper from one side. Okay, and I'm gonna apply load at the end. Okay, Once you apply load at the end, what are you expecting? You are expecting that your stack of paper will go downward like this, will bend like this downward, right? So now, guys, we need to clarify something. If you look at the upper layers, of course, we are assuming that this stack of paper are still in the same plane. Okay. So if you are assuming that your stack of paper is still in the same plane, this means that the upper layer for the beam to take this situation or to take that form, the upper layer should be extended. You agree, guys?
Yes.
You got
Yes, we are.
I didn't understand you, doctor.
You did not what?
I didn't understand what you mean by that.
Okay, assume that you have a bunch of paper in your hand, Muhammad. Okay, and you are holding this bunch of paper from one side, and at the end of this bunch of paper you added a force such that this force will make this bunch of paper bent down. Okay. If you are assuming that the ends of the paper will be in the same plane, I mean that one, you see this one that I'm hatching right now?
Yes.
Okay. So to keep all the ends of the paper at the same rotated plane, this should be satisfied only in one case. If the upper layer got stretched and the lower layer got contracted. You agree?
Yes. Yes.
Do you see this one? You see what I'm saying?
Yes. Yes.
Okay. So now, guys, let's look at the same beam, but from the side view, from the front view. Okay. Here is the new location of the beam after it bends. Okay. We all agreed now that all this, the upper layer got extended, which means that it is subjected to tension stress, which means all the points on that layer has a positive stress. And we also agreed that all the layers down there has, I mean, the lower layer got contracted. What do I mean by the only way for this layer to get contracted is to be subjected to compression stress, right? Am I right or wrong, guys?
Yes.
Right, right.
Okay. So now we're gonna assume that all the points on the lower layer has a negative stress. Okay. So mathematically speaking, guys, when you count from positive number to negative number, do you jump directly from positive number to negative number, or there is some neutral number which cannot be classified as positive or negative?
Yeah,
And
there
for
is a
example,
neutral.
if you are counting from positive 3, positive 2, positive 1, will we jump from positive 1 to negative 1, or we should have a 0? Okay.
Oh, we have a
Same
zero.
story, guys. Okay. Same story. You can see, guys, that the highest tension stress is located at the upper layer. And when you move inwards, I mean in this direction, your tension stress is getting smaller. And the highest compressive stress is at the lower layer. And when you move in that direction, your compressive stress is getting lower. So imagine that you are moving from positive 3, positive 2, positive 1, and then you will pass by a layer which will not stretch out, and it will not contract
Compress.
or compress. Do you get it?
Yes.
So now we can claim that that there is a layer somewhere here, and we can claim that this layer is neutral.
Neutral
layer.
line.
We can claim that this layer is called the neutral layer.
Yes.
You get it, guys? So if it's in neutral, this means that if I'm gonna give it a sign, there is no sign. It should have what? Zeros. You got my point?
Yes.
Okay, now I'm gonna draw it again. Here is the situation, guys. I'm gonna make it bigger. Here is the situation. This is your cantilever. This is the plane of rotation of that cantilever. I'm sorry, I don't know. It's not okay. Okay, no problem. So this is a cantilever again, and this is the plane of rotation, and this is our neutral plane. If we are trying to change this one from 2 dimension to 3 dimension, it should look like this. And this our neutral our neutral plane. Do you see how your beam will look like? So this one is neutral, this one is positive, this one is negative. Okay, so now I'm gonna get back to the side, to the front view again. Here is the beam again, or cantilever. Here is the rotated plane. Here is your neutral axis, and here is the way you should draw your stress distribution. As you know, guys, the biggest tension stress is at the upper layer, at this layer. All of these are positive. The biggest positive value here on these layers. Okay, so when you represent it, you represent it with an arrow which has the maximum length. And the more you go into the more you move into close to the neutral axis, these arrow lenses will become what? Smaller, 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 until you get to the point which is next to the neutral axis. And then once I cross the neutral axis, all these arrows will direction will be reflected. Actually, it will be on the opposite side. Okay, so now if you are trying to, of course, the change here is uniform, which means that if you are trying to draw a line between the first arrow on the tension side and the last arrow and the last arrow of the compressive side, you should end up by drawing this shape. So in our case, to make our life easy, we don't draw the cantilever in the deflection situation. We keep it as it is, assuming that this deflection is too small. But when it comes to the stress distribution, here is the way you draw the stress distribution. This is positive. No need to draw the whole arrowheads. Just one or two or three is enough. And this is the neutral point. And this is what? This is the compressive stress. I'm sorry. Arrow here.
في مشكلة في الصوت يا دكتور.
الصوت كده كويس الصوت؟
الآن تمام هنا.
طيب. So now guys, we see how again the voice has a problem.
Yes يا دكتور.
Okay.
I think it's a problem due to the connection.
Yes, the connection. The voice is clear, but the connection is not good.
Yeah, I think now it's okay, guys.
Yes, now it's okay. Yeah, now it's so clear.
Yeah, I think just one moment. Okay. So you hear me now?
Yes, doctor.
Okay, so now guys, as I mentioned, we physically were able to represent this stress distribution and show the variation in the stresses from positive to negative. And we found that, practically speaking, that if we need to move from positive to negative, I have to pass by a layer which is neutral, neither subjected to tension nor subjected to compression. So now I need to prove this one also through the form. The form tells me that your sigma bending is equal to m times y divided by I. Okay, m, we are assuming, guys, that our m is constant.
الصوت انقطع يا دكتور.
ما في صوت يا دكتور. في صوت يا شباب ولا؟
والله ماني سامع
لا،
شيء،
ما-
مكتوب عنده انه جوينينج.
وطلع الحين بيجون. عبد الله عبد القادر موجود؟
Okay, guys, I'm sorry for the problem with that connection. Okay, are you there?
Yes.
Yes, yes, دكتور.
Okay, so now, guys, we need to prove what we did graphically. We need to prove it through this form. Again, guys, the moment is a fixed value because we are always looking at the location which has the maximum moment. So we'll not think about the moment. Moment, keep it as it is. And now, let's move to the I. I is like a property of the cross section. Like as we mentioned yesterday, it is called second moment of inertia. Remember? Okay. And if you remember yesterday, we talked about what's called, we talked about J. And the J, what did we call it yesterday? If can someone remind me? What did we call this one?
Polar moment of inertia.
Polar moment.
Polar moment of inertia. And in the case of the circular cross section, it is pi over what? 32, right? Am I right or wrong, guys?
Yes.
Yes. 32.
Pi over 32
Yes.
d to the fourth, okay?
D to the power.
Now, what about I for the same cross section? I mean for the same circular cross section. This I is pi, but this time not over 60 over 32, it's over 64 d to the fourth. In other words, we can claim that for the circular cross section, your J is equal to I over 2. Remember this relation, guys. Okay, this is only for the circular cross section. So as we can see, guys, in this
So I
form,
think it's the opposite, right? I is equal to J over 2.
I equal to J over 2. Yes, sir. Thank you so much. So I is equal to J over A, J over 2. Tamam? So now, guys, if we go back to this form, this one is constant for the location. And this one is constant as long as your cross section is uniform. What do I mean by uniform? I mean from the beginning of the cantilever or from the beginning of the mechanical member until the end, it has the same dimension, the same shape. Okay? Now, so the only one that will affect the variation in your sigma bending is the value of what? Of the y. Okay? So what will be the value of the y? Assuming, guys, that you are facing the cross section from that side. So here is how your cross section will look like if you are facing that cross section. Your neutral axis will become a horizontal line like this. You see this one? This is our neutral axis. And then we can claim that our positive y is going upward and our negative y is going downward. Okay? So as you can see, guys, if you are trying to measure the distance between the farthest point on the top layer and the neutral axis, you will end up that this farthest point has the maximum tension stress. Why? Because actually, because of the distance is the biggest distance, not only this, the value of the y is A. I mean the sign of the y is positive. You got it? So what about the lower layer? The lower layer, it has the same y, but the sign in this case will become a negative, which means that the lowest one has the maximum compression stress, and this is exactly what we found in the stress distribution. Okay, so what about the points which are located on the neutral axis itself? What will be the value of the y, guys?
Zero.
Zero.
And then you will end up with zero stress. This is why your stress distribution, the graphical representation, is consistent with your equation. I'm pretty sure, inshallah, that with this explanation, you will never ever forget this form in your life. Okay? So now, alhamdulillah, we are able to finish the third type of stress, which is the bending stress. Remember that we did not leave the simple stress yet. We are still sitting under the umbrella of the simple stresses. What will be the fourth type of stresses, guys, that can be classified as simple stress?
Bearing, maybe.
Bearing stress. What do you mean by bearing stress?
I think it's type of compression stress. When it's like when you sit in a chair. So you are sitting in a chair and the chair is sitting on the ground. This is bearing stress.
Bearing stress. Who is speaking?
زياد الشمالي.
Shukran Ziad. Who else can give me explanation for the fourth type? He called it bearing stress. Does it have any other name, guys, other than bearing stress? Does it have any other name other than bearing stress, guys? So what is the cause for bearing stress then, guys? What is the cause? What will lead to this kind of bearing stress? Is it the same mechanical component, or it's coming because is the compressing or sitting down or settling down on another mechanical component?
Can you repeat the question, please, doctor?
The question is, you guys said that the fourth type is called the bearing stress. So I'm asking if there is any other name for that kind of stress other than bearing stress. Ziad told us that it's bearing stress, and he started explaining like when you sit on a chair and this chair is touching the ground at some points. So at the location of touching the ground, you can find that bearing stress. Can we give it another name which is does make more sense for us?
Maybe, doctor, it's the same as the friction stress.
Friction?
The friction force. Yes.
No. We don't have friction here, man.
Contact.
Allah
Normal
ينور عليك.
stress, maybe.
Allah ينور عليك. Contact stress. Very simple, guys. There is a mechanical member contacting another mechanical member. Then you will end up with contact stress, and this is the most common name for that stress. Okay. So we can claim that the fourth type of stress is the contact stress. This is stress number 4. Contact stress or stresses. Sometimes we call it bearing, which is coming from the word bear. Bear يعني معناها afford، يتحمل حاجة، شايلة حاجة فوق في كتافها. You got the point? The bearing stress. What else we can give it? There is another name called the Hertz stress.
Doctor, can we call it crashing stress?
No, crashing, not crashing. Crashing, C-R-U-S-H. No, it's not. It leads to crashing because, for example, guys, imagine that you are holding a chalk. You know, chalk اللي هي الطباشير. Imagine that you are holding a chalk in your hand and you are pushing this chalk against the blackboard, and you are strong enough, mashallah, to keep pushing until you see that this chalk will get crushed. Okay, but mainly it's crushed because of that contact stress. We cannot call it crushing stress or whatever you said before. You got it, man?
Yes, doctor.
So now we can say, as I said, the most common name is the contact stress. What is the contact stress? It is also sigma. Why don't we give it, guys, tau? Why we give it sigma?
Because tau is for shear stress, right?
Yes, tau for if your force is acting parallel to the cross section. But in this case, our force is still perpendicular to the cross section, so we cannot give it tau at all.
Force of stress.
Maybe because it has compression behavior.
Yeah, I told you. No, it's because of the direction of the force with respect to the surface. In the contact stress, imagine, guys, that this is, for example, like a mechanical member resting on a desk. Okay, this is our disk, and you are pushing the force here. Okay, so you have area number 1 and you have area number 2. Okay, guys, so now I can claim that the sigma contact in this case is equal to the force divided by which area, guys? A1 or A2? Or it doesn't matter?
A2, doctor.
A2, the
A2.
one
Like the small area, the small area.
Is
The
it the
small
small
circle.
area? You said A2 because it's the small area or because of another cause?
Because it's
Because that's the
contacting
area in
the.
contact with the, which is causing the stress to bear on the other object.
Allah ينور عليك. We are always, guys, looking for the contact area, which is A2. It doesn't matter if it's a big or a small. يعني in another scenario, what if I did something like this? Same force, A2 becomes up there, and the A1 becomes down there. I flip it
Then
over,
we'll consider
upside
A1.
down.
A1.
Then in this case, so to make our life easy, just say F divided by what is called area projected
Contact.
or area of contact. You got it?
Yes.
Okay. In some other scenarios, guys, for that sigma, still we are talking about sigma contact, okay, or sigma sub BR stands for the word bearing, or sigma sub HZ
صوت انقطع يا دكتور.
stands for الصوت قطع.
نفس المشكلة يا دكتور.
How about now,
بس
guys?
يتقطع يا
Now
دكتور. لا يا دكتور.
okay, guys. طيب, just let me tell you something. If something happened like this, just give me chance 1 or 2 minutes because it's in the connection, not in the voice. Okay?
Okay.
How about now? Now is okay?
Yes, it's okay.
Yes, دكتور.
So alhamdulillah. So again, guys, the third one is hertz, sigma hertz. See, I see that because if there is something wrong with the connection, I can see it even in the writing. The writing
نفس المشكلة يا دكتور، ما أنت لكن الصوت يروح ويجي. دكتور.
What do you think now? This is okay now?
Yeah, it's okay.
نعم تمام يا دكتور.
Okay. So I'm going. It seems like I'm going to replace the whole laptop. Anyway, this is sigma contact, sigma bearing, and sometimes we call it hertz. As I said, HZ. This sigma bearing or contact or hertz is equal to force divided by area projected. Okay. So now, guys, why I intentionally said area projected, not area contact? You'll see very soon why I said area projected. Let's assume, guys, that we have a circular mechanical member, and this circular mechanical member is resting down on a flat surface like this. Okay.
تسمعون شيء يا عيال؟
لا طالع فوق إن الدكتور غادر ويتم إعادة الاتصال الآن.
والله مشكلة.
Okay, guys, how about now?
تمام
It's
الآن.
totally clear.
Okay, I was using wireless, but now I connected direct to the Ethernet cable. I hope it will. I will not have that problem, inshallah.
إن شاء الله.
Anyway, so we said force divided by area projected, and for the projected area, I have two examples. I have that example, which is a circular bar or circular rod resting on a flat surface. In another case, I have the same circular. I have the same circular bar. Bismillah. You hear me, guys?
Yes, we
very
did.
Yes,
good.
doctor, we can hear you. Yes.
Yeah. So I have the same circular bar, but this time it's resting inside a circular hole or circular half circular hole, half circular groove. I'm sorry. Okay, like this one. Okay, guys. Assuming that these two circular bars are identical, which means that they have the same diameter and the same length. Okay, this one also has the same diameter and the same length of the first one. So let's start with the case number one, which is the lower case. What will be your area projected, guys, here in this case?
The
I think
touching
it will be a
area.
rectangle.
The area is touching the ground.
The area which is touching the ground, which is
half cylinder.
The D. Wait.
okay. I'm gonna hear from each one, guys, but I need to clarify this point. This is very important. You said area touching the ground. Your area which is touching the ground is what?
half cylinder.
Half cylinder all over the cylinder itself.
You mean if you are thinking about this half, the half of the circumference of that cylinder times the length, if you stretch it out like this and then you multiply it by the length, this will be the area of contact. Is that what you mean?
Yes, doctor.
Yes.
Doctor,
that
I
what
think
you
it
mean?
will be the rectangle. I think it will be a rectangle, not
Muhammad, I'm gonna get back to you, Allah. But I'm just discussing who is speaking now. Who said the area of contact?
Me, Ziad.
عمر.
Ziad or Omar?
Yes.
All of us.
All of you, okay. So Ziad and Omar are telling me that the projected area should be the area of contact. In this case, I'm gonna imagine that I took the half of the circumference of that shape and I stretch it out, which means, remember, the circumference of a circle is pi times d. This is the circumference.
Yes.
And if you are looking for the half of the circumference, this means that it's pi times pi times r, and this will be the length. So in this case, your area will become pi r times l. Is that what you meant?
Yes, doctor.
Okay, wonderful. Please don't leave. I'm going to ask you another question based on this. What will be your area of contact here in the case number 2?
Very thin line.
The bottom line. Because if this is a perfect circle, the only way that it will get in touch with the surface in a line.
Yes,
There is a point here. Could you please tell me the area of the line, then?
0.
0, right? Which
the
means
units,
that you.
doctor, will not be same.
Please let me finish. Let me finish. I'm discussing one of you guys. Let me finish with him. Okay? This way, actually, will not do anything. Let's get benefit from the class. I'm sorry, guys. Now, who is speaking with me, guys? Omar?
Yes, doctor.
Omar, based on your in your thinking that this area will become 0, right? Am I right or wrong?
I said the half cylinder.
No, I'm talking about case number 2. Who is saying that in case number 2 the contact area will be aligned?
رضا اللي قال.
Rida?
Hey, Rida, yes.
Okay, please, Rida. Where are you, Rida? Raise your hand. Okay. Now, Reda, do you have a mic or not?
I have some connection issues, so yes, I have a mic.
Okay, Reda. The contact area here in this case, case number 2, will be what? Will be a line. Didn't you say that, man?
Time.
Didn't you? Okay. So, and the area of the line is what?
Yes. Yeah,
What is the area of the line? You very simple.
Theoretically,
He
should
has
be
a poor
0.
connection again.
Theoretically,
Reda,
should be 0.
are you there, Reda?
Yes.
Okay. So the area will be
Theoretically,
0.
should be 0, but
Don't say but. Don't say but. I'll take you there. Now take the area which is 0 and plug it into the equation. Then your denominator will become what? Will become 0, right? And if your denominator becomes 0, this means that your contact stress is what? Is infinity.
infinite stress.
Do you know what does it mean if your
Infinite
contact stress is
around
infinity?
it.
Black hole.
Breaking a surface.
Do you see physically? What do you mean by a contact stress equal
Will
to
break.
infinity? Yes, your
break
table will
piece.
your table will actually will break down into will shatter, will vanish because of that stress. It's not accepted, of course. Otherwise, everybody will bring a circular shape, put it on the table. He will explode the table, which is not physically accepted, right? So now let's get back to the form that you did. There is a thing that you did not pay attention to, guys. I did not say the area of contact. I said at the beginning area of contact, but I get back and I used another expression, which is the projected area. Do you know what's the projected area in both cases, Muhammad Taha? I'm getting back to you, Muhammad Taha.
Yes,
what is the
doctor.
difference between the contact area and the projected area?
I think, doctor, the contact area is like the area which is like the total area which is in contact with between the two shapes. For example, in the first case is the half cylinder, but I think the projected area is
the
the
contact area. Okay, let me confirm on you on what you are saying. Lower your hand, please, Reda. Okay, I'm speaking to Muhammad right now. Okay. So now, Muhammad, you agree with me that the contact area in case number 1 is equal to pi r times L. Am I right or wrong? Okay.
Correct.
Now the contact area in the case number 2 is the area of the line. You are insisting. Please, Reda, lower your hand.
I have a connection problem.
Okay. So the contact area for case number 2 will be what, Muhammad?
It's a line.
Line, which is 0. Now let's
Yes,
get
the
back
area
to
is
the
0.
definition.
Yes.
Yes, let's get back to the definition of the projected area. What will be the projected area in case number 1? And what
I
will
think
be
a
the
rectangle.
projected area in the case number 2?
I think the projected area will be the rectangle because that's where how the perpendicular force is acting.
So you mean that in both cases the projected area will be the same? Is that what you are saying?
No. I'm talking about the first one.
So the first one will be a rectangle.
Yes.
This rectangle has a length equal to L.
Yes.
And has a width equal to what?
2r.
2r with diameter. You mean the diameter, right?
Yes, the diameter. Yes.
Okay, wonderful. I agree with you, man. Do you agree with Muhammad, guys? Anybody that does not agree with Muhammad that the projected area for the case number 1 will be a rectangle of dimension d times L, diameter times the length? Do you all agree with Muhammad about this?
No,
So
Doctor,
we have to.
by R.
Faisal, what did you say? Faisal, you
Yeah.
disagree
So
with him?
no, I'm asking. So we have to look at as like in top view perspective.
Yes, sir. This is why I use the word projection. People,
Okay.
you guys, you took a complete course about orthographic projection. If you project any shape, for example, if I give you a cylinder, of a diameter D and length L, and I give you another shape with a square cross section, but actually the length of that cross section is the same like the diameter of the cylinder and the same L. What will be the projected area in both cases?
The same.
The projected area is the plan view, which is a rectangle of D times L. Do you agree, guys, or you don't agree?
Yes.
Totally.
So why you are throwing the prerequisites behind your backs, guys? This is very important. The mechanical drawing is very important for the mechanics of material and for machine design 1 and for machine design 2 and for all your life as a mechanical engineer. So be careful, guys. I'm gonna take you back to the both cases, but let me draw them in. Let me have another one. So this is the case number 1, guys. Okay, this is the case number 1. And the projected area here in this case, okay, let me give it the third depth or the third dimension. Okay, the projected area here in this case, I'm not caring. I'm just caring about I'm not caring about the contact. I'm caring about the projection. The projection here will be what? Will be a rectangle which has a length L, the same length as the circular shape, and it has a width V. Do you all agree about this?
Yes.
This is the area projected. And in the other case, regardless of the contact stress or the contact area, how does it look like? The projected area will also be the same because you are projecting this one. So if you give it third depth like this or third dimension like this, then you will end up with the same rectangle, guys. D times L.
You're having connection issues again.
ايه؟
انترنت كونكشن ما نسمعك كويس.
نفس المشكله
كده
دكتور.
كويس طيب؟
اي الحين
كده
كويس.
كويس؟
اي الحين تمام.
طيب خدوا بالكم يا جماعه ان في جزء من المشكله سببها ان انا بعمل ريكوردنج للمحاضره عشان اقدر ارفعها لكم. خلاص؟
ايه
المحاضره بتتسجل، فكل ده برضو بيعمل لود على النتورك. خلاص، عشان برضو تقدر ترجع لها بعد كده. ف you have to excuse me for this. Anyway, so now guys, I can claim that the sigma contact in both cases, again you have a problem with the voice, right? Now it's okay. I can see it from the writing. So now I can say sigma contact or sigma projected is equal to force divided by D times A times L. It doesn't matter if you are talking about the first case or second case. Is it clear now, guys?
Yes, doctor.
Is it clear? So, alhamdulillah. So, this is actually the last type of stress or the last classification of the simple stress. So, let's go quickly through all these stresses that we covered since yesterday. We have normal stress, which is tension and compression. We have shear stress, which are 3 types. The first type, which is direct, single, and double. The second one is shear due to torsion. The third one is the shear due to a bending, or sometimes we call it transverse shear. And the third one is what? The bending stress. What is the form for the bending, guys? Sigma bending is equal to what?
MY على I.
What is I?
I is second moment of inertia.
Of inertia, yes, sir. Y, what is Y?
Y is the vertical distance away from the neutral axis.
It is the perpendicular distance measured from the neutral axis to the location at which you are trying to calculate your stress.
Yes.
Because we are not always looking, guys, for the stresses at the top layer and the lower layer. Yani, for example, in a case like this, let's assume that this is our cross section and this is our neutral axis. Maybe I'm looking for the stress at some point here for some reason. Okay, so your y in this case will be that distance. You got it? So we have y1, y2, y3. But if you say y, absolute y without any subscript, it means the maximum y, which is the y at the A, at the upper or lower layer. You got this one, guys?
Yes, understood.
Okay, alhamdulillah. And then, alhamdulillah, we ended up by calculating, by talking about the contact stress. And actually, at the beginning, I have a long discussion with you. There is a reason actually for this long discussion, guys, such that you will never ever, inshallah, forget it. And now you can see the difference between saying contact area and the projected area. There is a big difference between both. Okay, so these are the simple stresses. Now we're gonna move, inshallah, to the next stress, which is superposition principle. And after the superposition, we have to move to the compound A stresses. I'm gonna go through these stresses very briefly because, inshallah, during the course we'll talk about them in details. But there is another important thing, guys, that I need you to review, which is the I. How to calculate I for different cross sections, if you remember. Yani, for example, if you have a circular cross section here, I'm gonna put like let me put a title here: how to calculate the I value, starting with a circular cross section. It doesn't matter if your neutral axis is horizontal or vertical or any direction. Okay, so this could be your neutral axis, this could be your neutral axis, this could be your neutral axis. By the way, guys, how can I define the location of the neutral axis for a uniform shape? There is a condition actually. Yani, for example, let me give you this one. I'm assuming, guys, that I have circular cantilever, okay, and it is fixed from one of the ends, and there is a force acting here at that end. Okay, how can I define the neutral plane or the location of the neutral plane? In this case, your neutral plane will be what, horizontal or vertical? Horizontal. Okay, what about this case, guys? Where will be your neutral axis?
Be vertical.
Vertical, okay. So we can end up actually for the uniform shapes that the neutral axis, it should be perpendicular to the plane of the moment, or it's perpendicular to the force. But be careful from saying perpendicular to the force, because sometimes it's tricky. Because in some cases you might have more than one force. Yani, for example, if I give you F1 here and I give you F2 there, can you tell me what is your neutral axis? You will never ever be able to tell me what is the neutral axis until you do what?
The calculation.
What do you mean by calculation? All our business in this school is calculations, man.
I mean, we'll have to calculate for both cases separately, right? Like in one case, the neutral axis will be horizontal and the other vertical.
No, Muhammad, no.
After finding the resultant force,
there is one neutral axis here in this case.
We should consider the moment.
Khalid is talking. Who is talking? Amjad?
Yes.
Amjad, I cannot hear you. Amjad, your voice is very low.
I said, Doctor, the resultant force.
Okay, Amjad al-Malki. What did you say, Amjad?
The resultant force. We find the resultant force.
Yes, I like your answer, man. See, guys, in a case like this, first of all, we have to come up with the resultant force and find the location of that resultant force. And based on this, we can say it's okay. If the resultant force is moving all the way to the back, then it will be accompanied with a moment. You see the moment, guys? شايف المومنت مايل ازاي? You see how it's taking the same direction of the force? Okay? And in this case, your neutral axis will be perpendicular to that line. This is why in a simple case like this, for example, if I'm talking about this case, your force is here, then in this case, if you move your force all the way back to the back cross section, then you will end up with a horizontal moment like this one. time. You got it, guys? It's very
Doctor, I don't
important to
understand
understand.
what you mean by that.
Okay, let me draw it again. Muhammad, I'm assuming that I have that again connection with problem connection.
Yes, Doctor, the same problem.
Okay. Oh, it's getting back. Okay. Hello? Hello? Hello?
ايوه يا دكتور سامعينك.
Okay. لا, still the problem is there. Still the problem is there. Just one moment. Can you hear me now?
Yes.
Okay, just one moment. Let me fix something. I think now it's okay.
Yes, Doctor.
Hello,
Yes, it's
Muhammad.
okay.
Can you hear me?
Yes,
Yes, Doctor.
Okay, I'm
I can hear
getting
you.
back to you, Muhammad. Okay. Now, guys, imagine that I have that cantilever with a circular cross section. Okay. And let's assume that there is a force. I'm going to speak about vertical force first, and then horizontal, and then combination. Let's assume that we have a vertical force here. If you need to calculate the moment at the end of cross section, what you need to do is just to imagine that you virtually move this force all the way to the back, and this force will be accompanied with a moment which is acting in this direction. Do you agree with me? And this moment will be equal to F times L, where L is the length of that cylindrical shape. Do you agree about this?
So the force at the back, you mean, like near where it's connected to the wall, right?
Actually, no. The force is not. This is, you know, there is a principle actually in the statics. When you move any force from a location to another, virtually, but the location, the physical location, is the location which is indicated in your figure. But when you move it virtually from a place to another, you know what virtually means, Muhammad, right?
Like not real, like.
Not real, yes. If you move your force from a place to another, it should be accompanied with a moment. And this moment is equal to the force times the distance that you moved this force virtually.
Yes.
Okay. So now you agree that the moment, your moment, which will be where your moment will be acting. My moment will be acting along that vertical plane, guys. You see that vertical plane because you moved your force along that vertical plane. So now I can claim that the direction of the moment or the plane of the moment is the vertical plane. Do you all agree, including Muhammad Taha?
Yes.
Okay. So now we claim that our neutral axis should always be perpendicular to the plane of the moment. So, as you can see, the plane of your moment is that vertical plane. Then you will end up that your neutral axis should be perpendicular passing by the center of the center of the cross section. So this will be my neutral axis for the first case. You got this one?
Yes.
Okay. Now let's move to the next case. I have the same beam. Okay. But in this case, my force is acting from that direction. Let's say that my force is acting horizontally from that direction. Okay. And your beam is fixed at the end. Now, when you move your force virtually, you will move along that horizontal plane. Do you agree?
Yes. Yes.
Yes.
Okay. So here is the plane of your force, and it is also the plane of the moment. What do I mean the plane of the moment? Imagine, guys, that this plane is as if it's a blank paper, and you are holding this blank paper on your hand in a horizontal position. And I'm asking you to draw the moment. You'll tell me it's okay. I'm going to draw the moment on the paper itself, on the surface of the paper, which is like this. So now I can claim that the plane of my moment is horizontal or vertical?
Horizontal.
Horizontal. Where did you draw the moment?
Horizontal.
Yeah.
Okay, horizontal. So I can claim that the plane of my moment is horizontal. In this case, you will be able actually to locate your neutral axis for the second case. Again, what is the neutral axis? What is the condition for the neutral axis? The first condition that it should be perpendicular to the what?
The
to the
force.
plane of the moment. But you have actually infinite perpendicular to that plane. You can draw a perpendicular here or there or there. No, there is another condition, that this neutral axis or this perpendicular should pass through the what?
Center
The
of
center
gravity.
So I can claim that this is the neutral axis for the second case. Okay? Clear, guys?
Totally clear, doctor.
Now, let's move to the third case. Amjad, remember what did you say, Amjad? I have F1 here, Amjad al-Malki. And I have F2 there. Where did you go, Amjad?
Here, doctor.
Are you there, Amjad? Amjad, are you there, man? Amjad al-Maliki. Okay. Anyway, can you hear me, guys, all of you?
Yes.
Where is my reference?
Yes.
Yes, doctor.
Okay, Omar, where are you, Omar? Did he leave or what?
Yes, doctor. Yes, doctor. Everything is okay.
Okay, shukran, Omar. I thought that you went to the kitchen, you felt hungry or something like this. Anyway, so we have F1 and we have F2. Now, if you remember what Amjad said, guys, I cannot decide where is the neutral axis, and not like Muhammad Taha said, I have to deal with each one separately. No, we have to end up with only one neutral axis. Okay? So the very first step is to think about where is the location of the resultant force. And of course, you know, guys, how to find that location, or how to find the resultant. The resultant force is equal to what? The square root of F1 square plus F2 square. Am I right or wrong?
Yes, you are right.
Right.
And imagining that this is your F2 and this is your F1 moving in a series, then I can claim that the inclination angle theta here, theta is equal to tan inverse of F2 divided by F1. Do you all agree, guys?
Yes.
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 Okay. So now I can draw the plane of the moment. If this one is making theta, then I can go to the center and draw another force making the same theta at the back, and then connect this one with that one. You see, guys, the plane معلش هو هيطلع شبه المعين كده. Okay, do you see that shape? You got this one?
Yes.
Doctor, I have a question. When we were doing the mechanics of material course, we did we took two neutral axes, like for both cases we calculated, and then we joined the values. That's what
No,
I'm confused
actually,
about.
see, if you are talking about the total, there is only one neutral axis, by the way. There are no neutral. See, you did not get the meaning of the neutral axis, Muhammad. If you remember this stack of the paper and I let it go down, bent down under the effect of the force, and I told you that the upper layer is get stretched and the lower layer get contracted, and there is a layer that did not suffer from anything in between. This is the meaning of the neutral. Neutral means neutral.
Yeah, I agree with you, but I was wondering, why did we do it the other way in mechanics of material?
Wallahi, don't ask me. You have to ask the instructor. So please don't get into these
Doctor,
details.
because even in the book, it's not just the instructor. Even in the book, we had it that way.
You have it that way?
Yes,
Okay,
the
we can discuss it.
calculations were.
No, but I'm talking about, see, man, book is not Quran.
Yes,
book is not Quran. Don't tell me whoever writes the book is a man like me and you. Okay?
Yeah.
Now, did you get it physically? Did you get it physically? Did you understand
Yes,
the
I
meaning of
understand.
the neutral axis?
Yes.
Then, which one you trust? Whatever you say in front of your eyes, or whatever is written in the book?
Yes, I
No,
trust you.
see, man, you are an engineer. You know what engineer means? You are always thinking under your feet. Don't let it go like this. Don't memorize. You are not memorizing. You are understanding.
True.
Am I right or wrong?
Yes,
maybe
doctor.
in a neutral axis. See, the book can maybe he spoke about it in this way. He said it's okay. I'm going to deal with each force separately. And if he dealt with each force separately, then he can claim that he has two neutral axes. But physically, practically speaking, You cannot have more than one neutral axis. Neutral is neutral, man. Neutral means it is the plane where there is no stress taking place at all. You got my point?
Yes, doctor.
Okay. So now everybody is okay now, guys? Did you get the meaning of the neutral axis?
Yes.
Yes.
Okay. Now let's
Great.
get back to our plane. We draw that plane. Remember that plane that we draw right now? Okay, let me draw it outside because the picture is getting complicated. Here is how the plane will look like, guys. Assuming that this is the total force at the front section, and this is the total force at the back section. And this one is making an angle theta here, and this one also is making an angle theta. You got the point, guys? It's as if you are holding a paper in your hand, and let all, of course, you stretch out the paper and you make this paper taking an angle theta with the disk, with the top of your disk. You see the picture now? Are you following me, guys?
Yes.
Yes, we are.
Yes,
We
yes,
can
it's
see,
clear.
we're following.
Okay, so this plane actually is like a paper, a blank paper, and this blank paper you are taking this paper, putting on the disk, and let this paper make an angle theta with the disk. You got it? Here is what I mean, guys. Imagine that this is your disk. This is of course your cross section, okay? And I'm gonna assume that this is the location of the first force, F resultant. I'm not gonna draw everything to avoid the complication of the shape. And then we have another F resultant at the back. Whoever is opening his mic, please mute it. Haidar.
نعم يا دكتور. نعم يا دكتور.
Turn off your mic, Haidar. Okay?
Okay.
So now, guys, you see this is the plane in which you virtually move your resultant force from the front cross section to the back cross section. Do you all agree about this?
Yes.
Yeah.
Okay, now tell me, I need to draw the moment. You'll tell me it's okay, very easy. I'm going to draw the moment on the top of that paper, on this paper. Here you go. You see the moments? You see how the moment looks like?
Yes.
Imagine that this is a white paper, and you draw a moment on that white paper, which is already making this angle. Now to get to the last step, where will be your neutral axis in this case, guys? I'm going to draw a line. See, I'm going to draw a line passing by the center of the back cross section, and I will let this line be perpendicular to the plane of this blank paper.
Yes.
And in this case, you will end up that this is your neutral axis, or this is a neutral axis that you are looking for. You got me, guys?
معناته لازم اقطع السنتر دائم يعني.
أكيد. احنا قلنا there are two conditions for the neutral axis. It should pass by the center of the cross section, and other thing, it should be perpendicular to the plane of the moment.
Yes.
You got this one, guys? I need to move on.
Yes,
okay.
It's clear.
Yes.
Yes.
Move on.
Now imagine that you are fronting your cantilever or your beam from that direction. Now I can see the cross section is right in front of me, complete circle. This is my FR. You got it? And this is my neutral my neutral axis. Do you all agree about this, that this is the left side view of that shape? Remember, guys, front view, left side view, top view. Okay, so this is your neutral axis. Now, where will be the location of the maximum tension stress? Assuming that okay, I'm gonna to help you out, because actually you are not sitting in front of me. I'm gonna make more than location, and I'm gonna give them some numbers, and you tell me which one has the maximum tension, which one has the maximum compression. Okay. Now what I'm gonna do, I'm gonna draw a line along the same acting line, or the same the same acting line of the FR, and I'm gonna give this one point number 1. And now I'm gonna put another one on the opposite side, and I'm gonna give it point number 2. And now I'm gonna go to this, draw a horizontal line, and this horizontal line will intersect with the circumference of the circle at point number 3, and this will intersect with the circumference at point number 4. First of all, guys, where will be the location of the maximum compressive stress? Don't answer until I pick up somebody. عزام Muhammad Faqih.
نعم دكتور.
عزام, please tell me where is the location of the maximum compressive stress?
رقم 2 يا دكتور.
عزام, speak up عزام.
رقم 2 يا دكتور.
عزام, I think you took machine design, sorry, you took mechanical drawing with me before, right?
أي نعم.
I remember you, okay. Thank you, Azam. Amjad, no, not Amjad. Ali Yusuf القراقوش أو الجراجوش.
Yes.
Ali, could you please pronounce your last name?
Ali Yusuf القرقوش.
Okay, Ali, please tell me, do you agree with Azam that the maximum compressive stress is at location 2?
Compressive what?
The maximum compressive stress. Remember, guys, this stress distribution for the bending moment, for the sigma bending, don't we have maximum tension and the maximum compression, and do we have neutral axis? Ali, are you following me, man?
Yeah, yes.
You are yes? You are with me?
I am with you.
Okay, tell me, Ali, do you agree with Azam that the location of the maximum compressive stress is at point 2? There is only 6 minutes left, guys.
I think yes.
You think yes? Okay. Now let's go to Abdul Malik Al-Hawas. Abdul Malik Abdullah. Abdul Malik, are you there? Do you have mic, Abdul Malik? Abdul Malik. Okay, I see. Abdullah Samir Al-Sultan. Abdullah Samir Al-Sultan. Abdullah, are you there? Okay, ما شاء الله. طيب. Abdullah Ali Al-Wabari.
Yes, doctor.
Yes, Abdullah. Where will be the location of the maximum compressive stress?
I guess like my friend says that's point 2.
Okay, so if it's point 2, then what will happen at point 1? I'm gonna go back to Muhammad Taha.
So at point 1 there will be maximum tensile stress.
Maximum tensile stress. Okay. Now, guys, Faisal Al-Ghamdi.
تفضل يا دكتور.
Faisal, what do you think about point 3? It has tension or it has compression?
It has tension.
Tension.
Yes.
Okay. And what about point 4?
برضو أنا.
What about point 4, guys?
Compression.
Compression. Allah ينور عليك. Okay, guys. So be careful. Then that when you say tension or compression, your neutral axis is no longer a vertical or horizontal. Yani, for example, if I need to calculate the distance between point 3 and the neutral axis, I have to project the point 3 on that neutral axis, and I have to measure this perpendicular distance, which is y3. You got this one, guys? And because of the symmetry, your y4 will be equal to y3. So I can claim that the stress as a magnitude at 3 and 4 are equal. But one of them is tension and the other one is compression. Do you all agree about this, guys?
Yes.
Yes, doctor.
Okay. So alhamdulillah, now we are able to imagine what is neutral axis, how many neutral axes we should have, because actually when you draw something like this, it will physically help you out to imagine and memorize. Inshallah, I promise that you will never ever forget this class. But there is still some complicated shape other than like circular and rectangle. Yani, for example, if I give you, let's start with another simple shape. What will be the second moment of inertia for this simple shape, guys? Assuming that this is your neutral axis, okay, and assuming that this distance is k, and this distance is h. What will be your I here in this case, guys?
1/12 k into h cube.
1/12 k times h cubed. Do you agree? Who is speaking?
Khalid al-Nasr.
Khalid. Do you agree with Khalid, guys, that it's 1/12 k times h cubed?
Yes.
Okay, so let's put it in more general
Yes.
form so you'll not forget it. Always for a circular, for a rectangular cross section, we are saying that our I is equal to parallel times perpendicular cubed over 12. And this will make your life easy. Why? Because when you say parallel to what? You have to say parallel to something, right? And our main job, our main business here today is about the neutral axis. So now when I say parallel, it means by default parallel to the neutral axis. And if you are trying to apply this form to the case which is drawn down there, then your parallel will be what? The k value. And your perpendicular will be what? The h value. But what if your case was something like this? And still this one is your k, and this one is your h. What do you think, guys, here in this case? What will be the value? What will be the value of the I?
It's the opposite, doctor. It's h k cube over 12.
Yes, this is why I recommend you actually to memorize this form, because some of the people got familiar with what's called bh cubed over 12. I remember that you say b, not k, but I intentionally wrote it k because I don't want to let you surrounded in that small box. No, just make it general. It is parallel times the cube times the perpendicular cubed over 12. Parallel to what? Parallel to the neutral axis. Perpendicular to what? Perpendicular to the neutral axis. And this will make your life very easy. Because in the first case, it will be k times h cubed over 12. And in the second case, it will be h k cubed over 12. You got it? Okay, I'm gonna end up my session here, but I'm asking you actually, as like you can consider it assignment, whatever. I'm gonna give you some shapes. Okay, what will you do, guys? You will, of course, you will solve on a blank paper, and then you scan it and you send it to me. Okay, I'm just one moment because I did not open the assignment for you, but I'm gonna give you the email. You can send it to me you can send it to that email. But let me give you the assignment first. Assuming, guys, that I have these different shapes. This is T. This is L. This is T1. This is L. L1. This thickness is T2. And this is L2. And assuming that your neutral axis here, of course, you have to define the neutral axis. Remember, there is something called the parallel axis theory. I'm not gonna review it because you already know it from mechanics of material. Parallel axis theory. So I'm asking you to calculate I vertical and I horizontal. This case. Sorry, just one moment. Okay, let me draw it here. I think there is a problem with the connection. Just one moment. I think there is a problem with the connection. I know.
Doctor, can you send that in the WhatsApp group? It's better.
Please write down actually because it's two simple shapes. I'm gonna give it to you. Okay. This is the second shape. 3. I'm sorry, not 2. And this is 2 T1. The distance from here to there is L1. This is T2. And this is L2. And the last shape is something like this. This is T1. This is T1. And this is T2. This is L1. And this is L2.
Doctor, I think you're having connection issues again.
Hello?
Yes. Can you hear me, guys?
Yes, we can hear you.
Yeah, please. What I need from you now is to just copy these 3 shapes from the screen and start working on them. And I'm gonna give you the email. Okay, I'm gonna write the email on the WhatsApp group because I'm not using the school email. It is full. There is another email. I think I sent it at the beginning of the semester. Did I send it at the beginning of the semester? No problem. Okay. Anyway, I'm gonna send it on the WhatsApp group, inshallah, once I finish. But I need everybody before he leaves to copy these 3 shapes from the blackboard, from the monitor right now, and start working on them.
Doctor, you mean by I vertical and I horizontal, I X and I Y?
Yes, sir.
Okay.
Okay. Yani for example, let me remind you something, guys. For the first shape, the I vertical, I mean your neutral axis is vertical. Okay.
Yes.
In this case, your eye is very straightforward. Okay.
Yes.
But
Yes,
for the second case, for eye horizontal, you have to locate what's called center of geometry first, and you let your neutral axis pass by this center of geometry, and then use something called the parallel axis to calculate. So it will, the horizontal for the second case, for the first case, will be longer. You got my point?
So we're gonna solve them as variables, huh? Without numbers.
If this is case, no, we're gonna solve them as
صوت مش واضح.
you got it?
Can you repeat that, Doctor?
I'm telling you that you'll solve them symbolically, like using a symbol.
Oh, okay.
There's no numbers there. Even if it's like I mean if it's like official assignment like assignment 1 or assignment 2 or like this.
الصوت غير واضح يا دكتور.
I'm telling you guys that whenever I ask for any assignment or any either it's official assignment or something to practice on, can you hear me now?
Yes, doctor.
Yes, we can hear you.
If I ask you for something like this, guys, we have to agree that when you turn it in, you should be neat and clean. Yeah, don't bring any paper and you just draw with a freehand sketch. You have to use ruler and the pencil and all this stuff. Not only this, I need everybody to create a cover on the Word. Okay, this cover has the logo of the school. It has your name, your ID, the name of. You write down if it's assignment 1 or assignment 2 or assignment 3. Okay, you create this cover on the Word, and then whatever you write down with your hand, you scan it and you combine them in one. You got my point, guys?
Doctor, you're having connection error.
الصوت ما
Can
كان
you hear
واضح
me?
يا دكتور، كلمة نسمعها وكلمة لا.
Now can you hear me?
Yes. Now,
Doctor,
Here is
can
the
you load this
instructions
on
there.
Blackboard and give us the announcement there so it's easier for us to understand what to do?
No, it's already recorded, Muhammad, please. I have no time to do anything on the Blackboard today. Listen to me carefully, guys, okay? And you already have this lecture, you will have it recorded. So it will be in your archive all the time. Again, guys, I'm asking everybody to create a cover page. This cover page has all information about you as a student and the college. And it should have the cover like any regular cover page you put it for any other classes, guys. You put the logo and then your name, your ID, and then the section number, okay? And then you put the course name and the course code, and then you end up by the name of the instructor. You got my point, guys?
Yes.
You keep it as a Word file. And then from time to time, what you need to change is the name of that assessment. You can call it assignment 1, you can call it quiz 1, you can call it quiz 2 based on the situation. And you keep this one. As a Word. And on the other side, you start working on a regular drafting. When you finish up your business, I said you make your working on a blank paper. Do you hear me now?
Yes, now we hear you, Doctor.
Okay. So you make your assignment on a blank paper, 1 page, 2 page, 3 page. It's up to the situation. And then you scan them, guys, and you put them as one PDF file with the cover. And you send it to me. Not only this, please remember, because we need to be very, very neat and we need to be organized. From now on until the end of that semester, you will have a folder. This folder, in each time, you will create a folder for the new assessment or new assignment, and you will keep all whatever you turn it in that folder. In case I requested for the second, maybe for some reason I lost your assessment or you don't see your marks, and when I searched my pocket here, I cannot find it. Then you have to send it, and I ask you to send it back to me. You have to be ready for this. You got my point?
Yes, understood.
You got my point?
Yes.
Not only this, I need everyone to keep hard copy from everything. Don't trash it, guys. Because maybe by the end of the semester, they will ask us to collect these hard copies from you. Is it clear?
Yes, it's clear.
Everybody got it?
Yes, Doctor.
Yes, Doctor.
Any other explanation that you need from me? Again, cover page has all the information about you as a student, the college, and the course, and the instructor. And every time, whatever you write with your hand, you scan it, and you make it with the cover page as one file, and you send it to me. You keep copy from that file in your folder, create a folder for this course, and each time you create inside folder for the new assessment. Not only this, you also keep the copy of the hard copy from whatever you turn it in online. ماشي يا رجاله اتفقنا؟ Do we agree?
Yes, we agree. Doctor, one small question.
Go ahead, man.
What is the deadline for this practice assignment?
This one should not take more than I can say it's okay. I'm gonna take it from you this coming Sunday, but it should not take more than 2 or 3 hours. If you remember, okay.
Yes.
For the first time, I'm gonna make your life easy. You are just warming up. We did not get into deep into the course. I give you. Do you all agree about coming Sunday, guys?
Yes,
I mean the deadline is coming Sunday.
Yes, yes.
Okay. The earlier you send it, the appreciation through the marks, you will get it. You got my point?
Yes.
Okay. Thank you so much. I hope that you enjoy this class.
Thank you, Doctor.
Okay. By the way, it took a while for the system to send me the recording. Once I got the recording, I'll send it by the end of the day, or maybe tomorrow morning, inshallah. As I did with the lecture of yesterday. Okay. You have. I used to send the URL in the announcement. Please check your Blackboard today. You will find the link for the first for yesterday lecture. Okay. Yes. You can watch it online, and you also, I think you are able to download it. I give you the permission to download it at the same time.
Yes, Doctor. Thank you.
Okay. See you, inshallah.
See you, Doctor. Assalamu alaikum.
Assalamu alaikum.
Alaikum assalam.